Alright, hello everyone. Welcome to today's lesson on operations with fractions. Alright, so last time we learned about dealing with fractions, converting between fractions, all that. But today we're actually going to add, subtract, and multiply, and do all kinds of fun stuff with them. Alright, so last time we talked about the greatest common factor. This time we're going to learn about the least common multiple, or the lowest common multiple. Right, and the method is the same. Right, so for the least common multiple, it is the smallest number that two numbers can multiply into. So it's almost the same method, right? We divide each number repeatedly by a prime number. Again, those are numbers that can only be divided by one or itself. So once again, things like 2, 3, 5, 7, not 9, 11, so on. Right, there's no 4 here, for example, because 4 can be divided by 1 and 4, but also 2. Right, so it's not a prime number. And yes, all even numbers are not prime numbers because they can be divided by 2, except for 2. Okay, after that, we write each number as a product of the primes, or product of prime factors. Right, we multiply all the prime numbers together, and then we select the most number of times each of the prime factors occurs in one number. So what did all those gibberish mean? Right, so let's take 24 and 36 again. Right, we want a prime number that can divide into 24. So we can always start off with 2. Right, 2 is even, or 24 is even, so it has to be divisible by 2. Right, again, we know 24 is divisible by 4. But 4 is not a prime number, so it has to be 2. You get 12. Once again, that can be divided by 2. Here's 6. 6 can be divided by 2, or can be divided by 3. Doesn't really matter. Right, 3 and 2 are both primes. Next is 36. Right, they can be divided by 2. 2 gets 18. 18 can be divided by 2 again. 2 gets 9. Which is 3 and 3. Alright, next, we write this as a product of primes. So 24 equals to 2 times 2 times 3 times 3. Right, so it's pretty much everything on this left column up here. Those are the prime numbers that we divided it by. Same as this. 36 is, oh, hold on a second. Sorry, it should be 2 here. There we go. 36 is 2 times 2 times 3 times 3. Alright, and now we notice here that in 24, 2 appeared 3 times. Whereas in 36, 2 only appeared 2 times. Right? So we select the time where this number appeared the most. Right? So in 24, 2 appeared 3 times, whereas in 36, 2 appeared only 2 times. So we select the one that appeared 3 times. With 36, we notice here that 3 appeared 2 times, whereas in 24, 3 only appeared once. And lastly, we just multiply everything together. So the lowest common multiple, or the LCM, is 3 2's and then 2 3's. Multiply all that out is 72. Okay, so which means that the lowest common multiple of 24 and 36 is 72. It is the smallest number that those numbers can multiply into. Right, we can see that 24 times 3 gets us 72. 36 times 2 gets us 72. Right, it's the smallest number. Right, there's like an infinite number of numbers that can be multiplied by 24 36. Right, but we want the smallest one. Right, so same as the next example. We divide by 9 by 3, it's a prime factor. Divide 18 by 3. Or 2. 3, we can try 3 this time. So you got 6. 6 can be divided by 2 or 3, doesn't matter, 2 or 3. 45 can be divided by 5, just 9. 9 can be divided by 3 and 3. We get 3. Once again, we list out the prime factors. So 9 is 3 times 3. 18 is 3 times 2 times 3. 45 is 5 times 3 times 3. Right, as you can see here, 2 appeared once. So, oops, here we go. 2 appeared once, right? So, we'll just leave it. 5 appeared once. Again, highlight it. And as you can see here, 3 appeared twice in all those cases. So we can just pick whatever one that works. Let's just pick the 45 one. Right, because 3 appeared twice in all cases, we don't have to highlight 3 repeatedly. Right, we can just highlight it once. So the lowest common multiple is we got a 2, we got a 5, and 2 3s. Which is 90. Alright, you can double check, right? 9 times a 10 gets us 90. 18 times a 5 gets us 90. And 45 times 2 gets us 90. Again, it's the smallest number. So why do we do all that? Alright, so once again, this is a method you can use that's guaranteed for the lowest common multiple. If you just want to guess and check, that's completely fine too. But the reason why we care about denominator or the lowest common multiple so much is for adding and subtracting. So when we add or subtract, if the denominator is the same, right, we can just add and subtract the numerator. Right, leave it be. If not, which is probably most often, if it's not the same, the denominator, we have to now rewrite everything with a least common multiple or least common denominator. Same idea. And if we need, we also have to convert improper fractions into mixed numbers. A lot of steps, but here's what it looks like in practice. We got 3 over 8 plus 1 over 8. We notice how the denominators are the same. So, nice and easy. Denominator stays the same. Numerator gets added. 4 over 8. But remember, we always have to reduce. Right, 4 over 8, technically that's the correct answer. But we have to make sure that it is reduced. So, we know that both of them can be divided by 2. So, it can be reduced down to 2 over 4. Once again, both of those are still divisible by 2. You can reduce it down to 1 over 2. Right, it cannot be reduced any further. Next one, 3 over 5 plus 3 over 10. Unfortunately, the denominators are different, so we have to make sure they're the same. And in order to do that, we find the least common multiple, the least common denominator. So we could do the complicated process I introduced earlier. Oh, we noticed right away, it's like, okay, if we just multiply 5 by 2, we get 10. And that's it. Right? And you're correct, right? All we have to do is multiply by 2. So if we multiply the bottom by 2, we also have to multiply the top by 2. So this becomes 6 over 10 plus 3 over 10. And now they are nice and even, or the denominators are nice and even, nice and same. They're just the same. So denominator stays the same as 10. 6 plus 3 is 9. We're done. Can I reduce it? And in many cases, some numbers or some fractions are a little harder to find, or far harder to spot the lowest common denominator. So in this case, 4 and 3. Once again, we can use the method from earlier, and we can break it down. 4 is just 2 times 2. 3 is just I guess 3 by itself. Alright, the smallest amount of times each factor occurs is literally just a 2 and a 3. So the lowest common multiple or denominator is 2 times 2 times 3, which is 12. Right, so we can multiply this by 3 to get a 12, and then this one by 4 to get a 12 at the bottom. From that, on the right side, right, 4 times 3 is 12, 3 times 3 is 9, minus 3 times 4 is 12, 1 times 4 is 4. And then denominators are the same. Leave that be. On the top numerator, 9 minus 4, which is 5. And we're done. Alright, just like that. Of course, like I said, this method guarantees you find the lowest common multiple. But if you want, you can give it a few guesses. And if you can guess it to 12, doesn't really matter. You don't have to use the method. Next, mixed numbers and fractions. Alright, first things in business, make sure the denominators are the same. 4 over 6, and then 4 and 5 over 6. And then we convert mixed numbers into improper fractions, so it's easier to work with later. So, as a reminder, to go from mixed to improper, we multiply the whole number by the denominator, and then we add the numerator. We add the top number. Keep the denominator. 3 times 6 is 18, plus 4 is 22. Like that. Minus, alright, 4 times 6 plus 5. Alright, whole number times the denominator plus the numerator. You get 29. Oops. 22 minus 29. Alright, so remember from the previous lessons, if the number, or the second number is bigger, then it's going to be negative, right? So it's a smaller number minus a bigger number. So we know it is going to be negative 7 over 6, right? 29 minus 22 is 7, and because we know the second number is bigger, it has to be negative. Right, and that's our answer. Or if you like, you can also convert that into an improper fraction. Right? 7 divided by 6 can go into there one time with a remainder of 1. So it's going to be negative 1 and 1 over 6, like that, as our improper fraction answer. Right, as of right now, we should always try to put our answers into improper fractions as good practice. But later on in higher grades, we actually don't really care about improper fractions or mixed numbers. Right, but for now, it's good practice. Okay, multiply. This is a lot simpler. Alright, so when we multiply, this is what we are doing here. Alright, let's say we have 1 over 4 times 2 over 3. Here's 1 over 4, right? 4 parts was 1 shaded in. 2 over 3 is 3 parts, 2 shaded in. We multiply it together, right? We just take the part where both of those shapes intersect. Right, which is just 2 out of those 12 grids. But we notice here we can actually reduce it. Right, to just be 1 out of the 6. And that's how we reduce. It's the exact same number. It's just smaller numbers to work with. So naturally, we don't like mixed numbers. We can convert everything into improper first. Right, so we keep the denominator, multiply denominator in the whole number plus the remainder to get 9. And from here, we just multiply numerator by numerator, denominator by denominator. So when we multiply, the denominator actually changes. So 2 times 9 is 18. 3 times 4, 12. Right, we can reduce it. Right, we notice here both of those, oh, not by 9, both of those are divisible by 6, which is 3 over 2. And lastly, improper fraction. Right, 2 can be going to 3 one time with a remainder of 1. So 1 and 1 over 2. Just like that. Now how about just a whole number? 3. Right, a whole number, we can treat it as that number over 1. Right, all whole numbers are just the number over 1. We're just too lazy to write it. Right, 3 is just 3 divided by 1, which is 3. Times 2 over 7. Multiply the top, the numerator together, 2 times 3, or 3 times 2 is 6. 1 times 7, 7. That's it, 6 over 7. Done. With division, right, the second fraction just gets flipped, and then we multiply as usual. So, with 3 over 4, we are multiplying by 5 over 2. Right, so all we're doing here is literally just flipping whatever fraction we're dividing it by. Multiply the top, which is 3 over 5, 3 times 5 is 15. Multiply the bottom, 4 times 2, which is 8. And put into improper fraction. 8 goes into 15 one time, with a remainder of 7. So 1 and 7 over 8. Okay, same logic. 4 is just 4 over 1 times 7 over 2. Right, we flipped the fraction being divided. Multiply the top, 28. Multiply the bottom, 1 over 2 is 2. Right, we can reduce both by 2 to get 14 over 1, which is just 14. Right, and we notice here that 28 over 2 is the exact same thing as just 28 divided by 2. Right, and as you can see, right, 2 goes to 2 one time. Right, 2 got 0, we move the 8 down. 2 going to 8 4 times with no remainder. Right, fractions, remember, fractions are literally just division. Okay, now lastly, reducing ahead. As you can see here, right, when we multiply everything, we reduce at the end, but those are some bigger numbers to work with. We can actually reduce the numbers ahead of time, so we're working with smaller numbers. And when we do so, right, we always make sure that we are reducing top and the bottom. So as you can see in this example, 3 and 15 here can both be divided by a 3. Alright, whereas, 4 and the 8 here can be both divided by a 2 or a 4. But we pick the biggest one. Alright, so that's what we mean by reducing ahead. So we can actually reduce this. Right, so now 3 becomes a 1, 15 becomes a 5. 4 becomes a 1, 8 becomes a 2 after reducing. So we are working with 1 over 2 times negative 1 over 5. Was the answer of negative 1 over 10. A positive times a negative is a negative. Because if we just did it as usual, we would have got to negative 12 over 90. If we didn't reduce ahead, 3 times 4 is 12. 8 times 15 is 90. Just kidding, it's not 90. It's 120. And of course, we can reduce that down to negative 1 over 10 because they can both be divided by 12. Right, so that's why we can reduce ahead. Instead of working with 12 over 120, it's just 1 over 2, 1 over 5 multiplied together. Same idea here. All right, when we reduce ahead, we always make sure we're multiplying them. So we flip this. Okay, now we reduce. 8 and 12, or 8 and 16. Right, they're both divisible by 8. So 8 divided by 8 is 1. 16 divided by 8 is 2. 5 and 15, both divisible by 5. 5 divided by 5 is 1. 15 divided by 1 is 3. Or 15 divided by 5 is 3. We also notice here it's two negative numbers multiplied together, so they cancel out to be a positive number. Final answer is just 2 over 3, and that's it. Right, so that's why we reduce ahead. It just saves us some time, but most importantly, we work with smaller numbers. Alright, and yeah, that's it for today's lesson. So, thank you for watching, and good luck practicing.